Okay, so I'm going to sketch the exponential equation. You can use your calculator to help you. So the domain, that's all the x values, and they go from negative infinity to infinity. Your range is all the y values. They go from 0 to infinity, but not including 0. 0 is a horizontal asymptote. It's continuous. Our graph is decreasing the entire time from negative infinity to infinity. There is no max or minimum. The boundedness is below because it has a horizontal asymptote. It does not keep going to negative infinity. It has no symmetry. It has a horizontal asymptote at y equals 0. It is not even or odd. And for end behavior, as x goes to infinity, our graph is approaching 0. And as x goes to negative infinity, our graph is approaching infinity. There's a few different ways you can solve 2a. The first is if we make 243 a base of 3, that's 3 to the 5th. Because each of these bases are now equal, x equals 5. Another way you could do that is to ln both sides, because that brings that exponent down to the front. Divide both sides by the ln of 3, and we'll get 5 as our answer with the calculator. B, I'm going to do the same thing. I'm going to get 64 to a base of 2. That's 2 to the 6th. So 2x equals 6, so x is 3. 125 is 5 to the 3rd. So 3x equals 3, so x is 1. Now for D through F, we have to use logs or ln's. We're going to ln both sides, and that brings the exponent of t down. We can divide both sides by the ln of 5, and using our calculator, we would get 1.209. Same thing here. I'm going to ln both sides. Divide both sides by the ln of 1. Oops. So we have to use our calculator. We will get 35. Now before we can ln both sides in F, we have to divide by 25. Now I can ln both sides. Brings the t to the front. Divide by the ln of 1.5. T is 3.419. So for this, we have to use the properties of logs. When we log a product, we can separate that with addition. When it's divided, we can separate it with subtraction. This one's going to be in a few steps because I'm going to need to take care of all these exponents. So now the exponent can become a coefficient. My ln's are looking like h's. Now we can use those same properties backwards. When we have addition, that can be simplified with multiplication. First, I need to make this an exponent. And that's all we can do there. And for this one, first, that's going to become the exponent. And now I'm going to have x over x plus 1 to the third. And I know it's division because of the subtraction. So when we simplify, say this equals x. So 2 to the what? 2 to the x equals 1/8. When I taught this in class, we used what I called the Roman numeral 9 rule. So 2 to the x is 1/8. Well, 1/8, I'm going to rewrite that as 8 to the negative 1. And I rewrite that again. 8 is 2 to the third. So now, because my bases are the same, x equals -3. ln of e, because these are inverses, cancel each other out, and our answer is -2. Before I can simplify c, I have to split it up. And again here, ln of e, so we're going to have 2 minus the ln of 2. Average rate of change is the same thing as slope of the secant line. So first I need to find out what f of -3 equals and what f of 5 equals, so I can find the slope between my 2 points. If I plug -3 into my equation, that equals -17. And if I plug 5 into the equation, that equals 119. So the average rate of change is the slope between these 2 points, y2 minus y1 over x2 minus x1. That simplifies to 136/8, which equals 17. So to draw a sketch of that, I would use my calculator to find out what x to the third minus 2x plus 4 looks like. It looks something like this. F of -3 is about here, and f of 5 would be way up really high at 119. So then to draw my secant line, I have to connect those 2 points. And the slope of that red line is 17. Average velocity, it's the same thing as the average rate of change, except now we're talking about distance over time. So I'm going to find the slope between 16 and 0. So looking at my chart, the y value at 16 is 66, and the y value at 0 is 2. And when we divide those, I have to include units with my answer. And it's feet per second. We're going to do the same thing for number 8. And we want the slope between 48 and 24. So the y value at 48 is 115. The y value at 24 is 85. Subtract those. You get 30 divided by 24, which is 1.25. So the average velocity is 1.25 feet per second. Now, instantaneous velocity is the derivative. It's the slope at the point of 24. So to find that, I'm going to find the slope between 32 and 24, and I'm going to find the slope between 16 and 24, and then I'm going to average those answers. I need my x, or my time on the bottom, the y values on the top. So to get the instantaneous velocity, I'm going to take those two average velocities and average them. So the instantaneous velocity when there is at t equals 24 is 2.1875 feet per second. So I already answered number 10. The average rate of change is the slope of the secant line. The instantaneous rate of change is the slope of the tangent line, and that is also called the derivative. So looking at our graph for number 12, the points where the slope is positive is where our graph is increasing. So that would be A, B, C. The tangent line at C is 0. G, we're increasing at G, so that's positive. So those are the only three answers for where we have positive derivatives or positive slopes of our graph. The negative points are D, E, and J. F is also 0. And the derivative is undefined at H because we cannot have a derivative at a sharp point on our graph.